Hi everyone, welcome back. In this video, we are discussing a very common senior level Java interview question. How would you design a singleton class and make it thread safe? This question looks simple, but interviewers ask you to test your understanding of concurrency, class loading, JVM guarantees, and defensive design. In this discussion, we'll focus only on production-ready solutions. First, we'll understand the static holder pattern, which gives us lazy initialization and thread safety without synchronized overhead. Then we'll move to the enum-based singleton, which is considered the safest and most robust approach in modern Java. We'll also explain why enum protects against reflection and serialization issues, making it the best practical choice in many real-world systems. A singleton guarantees only one instance of a class exists in the JVM, and every part of the application uses that same instance. Let's first understand the static holder pattern with a code example. We create a final class named holder singleton. We make it final to prevent subclassing, which protects singleton behavior. Inside this class, we declare a private constructor. This is very important. Private constructor ensures that no external class can call new holder singleton. So object creation is fully controlled inside the class. Next, we create a private static nested class named holder. Inside holder, we declare a static final field named instance. This field is initialized with new holder singleton. Now understand this carefully. The outer class holder singleton may load early, but the nested class holder is not loaded until it is referenced. When is it referenced? When getInstance is called for the first time. Now look at the getInstance method. It simply returns a holder.instance. The moment this line executes for the first time, the JVM loads the holder class. During class loading, static fields are initialized exactly once. Even if multiple threads reach this line simultaneously, the JVM ensures that only one thread performs the initialization. All other threads wait and then receive the same instance reference. That is why this pattern is lazy and thread safe without synchronized. Now look at the doWork method. This is just a sample business method to show that we can call behavior on the singleton. Now let's move to the enum singleton. We create an enum named enum singleton. Inside it, we define one constant named instance. In Java, each enum constant is created exactly once when the enum class is loaded. So instance is automatically a singleton object. We also define a method named doWork inside the enum. Now why is enum considered the safest singleton? Because Java guarantees enum instances are singletons per constant, and enum also protects against serialization and reflection attacks automatically. So in many modern systems, enum singleton is the recommended approach. Now let's go to the main method and understand the multi-thread test. First, we create a runnable named holder task. Inside it, we print the hash code of holder singleton dot get instance. Hash code here represents the memory identity of the object. If multiple objects are created, their hash codes will be different. Then we create three threads named H1, H2, and H3. All three execute holder task simultaneously. We start the threads and then call join on each one. Join ensures the main thread waits until all worker threads finish. Let's run the program, and you can see the output. All three threads print the same hash code. That proves they all receive the same singleton instance. Next, we repeat the same process for enum singleton. We create a runnable named enum task. Inside it, we print enum singleton dot instance dot hash code. Again, we start three threads. All print the same hash code. That proves enum also guarantees single instance across threads. Finally, we call doWork on both implementations. This shows normal business logic execution. Let's run the program and observe the output. All 3 threads print the same hash code. That proves they all receive the same singleton instance. Now why is enum considered the safest singleton? Because Java guarantees enum instances are singletons per constant. And enum also protects against serialization and reflection attacks automatically. So in many modern systems, enum singleton is the recommended approach.